This is example number 2, balancing equations. I got a little bit of a head start by setting up my two sides already, my left side and my right side. We have carbon, hydrogen, and oxygen on each side, so now we have to go through and count them. So carbon over here we have 2, yes? Yes. Hydrogen 4, oxygen 2. Remember, I'm getting that from counting these subscripts. 2 for oxygen, 4 for hydrogen, 2 for carbon. Over here, carbon, we have 1. Oxygen, we got to count all of it. So 1, 2, and then the 1 over here for a total of 3. And then hydrogen, we just have 2. Now we've counted all the atoms on each side and we realize that none of them are equal, so we need to balance the equation. Meaning we start off with carbon, because remember in our rules we always leave hydrogen and oxygen for last, so we're going to start off trying to balance carbon. We have 2 carbons over here and 1 carbon over here. So what is the simple solution for that? We just multiply this carbon by 2. So we'd put a 2 right there in front of this CO2, which would make carbon 2. So boom, cross that off. We now have 2 carbons. The only problem with that is it also changed the oxygens, right? Because if we put a 2 here, it's affecting the whole compound. So 2 times 2 with the oxygen means we now have 1, 2, 3, 4 oxygens, and then 5 instead of 3. So now we have 5 oxygens. A lot of crossing out is going to go on here, but we have 5 oxygens now. So we have our carbons balanced. Let's go ahead and try to balance our hydrogens now. So hydrogens will balance next, and with our hydrogens, and someone's at my door but I'm not going to answer it, with our hydrogens we take this and we would multiply this by 2, cross that off. 2 times 2 is 4, so that's going to equal that out, right? Because we have 2, 2, that's going to equal 4, and we have multiplied the oxygen by 2 as well, because we put it here, it's got to equal here too, right? Because we have 2 times 2 is 4. That also means we have 1, 2 oxygens now. Add that to the 4 oxygens we have over here, 1, 2, 3, 4, and that's going to give us a total of 6 oxygens now. See how oxygen has changed a bunch? That's because it's on the back end of some of these molecules and we have to keep changing it. So we put a 2 here, that changed it to 4, and a 2 here, that changed that to 2. 4 plus 2 is 6. So now our carbons are balanced. Our hydrogens are balanced. All we have left to balance is our oxygens. We have 6 over here, so we got to look to over here. Our oxygen is actually going to be really easy because our oxygen's all by itself. So the coefficient we put in front is only going to affect the oxygen. What times 2 is going to give us 6? 3. 3 times 2 is 6. So if we just put a 3 right there, we have 3 times 2, and that is going to give us 6. Now let's check and make sure we're balanced. Carbon over here, we have 1, 2. Carbon over here, put the coefficient, so we have 2. Hydrogen, 1, 2, 3, 4. Hydrogen, we put the 2 here, so 2 times 2, 4. Oxygen, here we put the 3 coefficient in front of this, so we now have 3 times 2 is 6. And over here, we have the oxygens in 2 separate compounds. We have 2 times 2, which is 4, and then 2 times 1, which is 2. 4 plus 2 equals 6. So our equation is balanced with these different coefficients put in front, 2, 4, and 6. That's example number 2. You can check out example number 3 next. Farewell.